Here we go, guys. Object-oriented design. To date, as we are developing our algorithms, really what we've been looking at is the sequence of events that can help us get through a problem, right? So all of our solutions have been essentially procedural, sequential type of exercises. So the big leap we're having here is that we are going to move kind of a step back and say, let's not just look at the sequence of events that happens as we are building a program. Let's look at the interaction between things in our program. Things can, and I'm not trying to be vague. This is the challenge of object-oriented design is that it really can mean anything. It can be a tangible thing that you can point to. So a student is an object, or a car is an object, or a television is an object, or a laptop is an object. Or it can be classes of things that you can't really point to. So I can point to a student, but I can't point to a college attendee. I can point to a Ford. I can point to a Toyota, but I cannot point to a vehicle because that's really not specific enough. And here in chapter 11, starting on page 192, that's some of the things that we're going to start looking at as we delve into object-oriented design. So first off, what is an object? An object is something that you can point to. An object is something tangible. It is a thing that you or your program are going to interact with in a meaningful way over the execution of the entire arc of your program or your procedure. So here the example in the text is a milk jug, which okay, but I like to, I'm a car example at heart, or just a car example waiting to happen maybe. You can point to a Ford Mustang, you can point to a Ford F-150, you can point to a Ford Focus, and you can say that all of those are objects. From there, we need to take a step back and say that each object is really just a part of a class. Now, a class is a grouping of objects. So we could say that, sticking with the car example, that a vehicle is really a class, right? Because I can't really point to a vehicle and say that that has something tangible, something I can, absolutely put my hands around. But I can say that, all vehicles have a number of wheels. All vehicles have doors. All vehicles have seats. All vehicles have, a collection of attributes. And since I'm skipping ahead a little bit, you can see attributes on page 193. An attribute is just a characteristic. It's something that I can use to describe an object. It's something that I can use to essentially differentiate between one object and another. So a Ford F-150 is a vehicle, and a Honda or a Honda Nightwing, a motorcycle, is a vehicle. They all have a number of wheels, 4 versus 2. They have a number of seats. It depends on the Ford F-150 you're talking about, versus 2 on a Honda Nightwing, so on and so forth. Other attributes would be number of cylinders, so 4, 6, 8 versus 2 in a motorcycle. So attributes give us a way of describing an object and keep on describing an object until we have something that is perfectly unique to that one object and only that one object. If we bounce back to the top of 193, we can kind of see the interaction between an object and a class. An object has the following things that are true of it. Number one, it has an identity that is unique for the lifetime of the object. What we're saying is there is a one-to-one unique identifier for every, we call it an instance of an object. So it's that very one and that very only object. For you as, I guess, a citizen, it would be your social security number. For you as a student, it would be your S number. For your car, it would be your VIN number. If we look to our phones, they have it's called an IMEI. That is a unique identifier. So this is absolutely positively a feature of every object, is that they have a unique identifier. Number two, we have a collection of data for each of those objects. And in that collection of data, we call it characteristics. The important thing here is that from one object to another object to another object, we have a full and complete set of characteristics that all objects share together. So what that means is, if we look at a student, let's say for a student object, students will absolutely positively have a student ID number. They will absolutely positively have a social security number. They will absolutely positively have a first name, a last name, an address. Remember again that address is going to be broken out into several different pieces. They're going to have all of those, because if any of those characteristics is missing, what essentially we have is bad data. So that means if I was to open up the school's worth of records and find that I am pointing at your record right now, you do not have in your set of characteristics a student ID number. That essentially means that your piece of data for that, the object it is that we have instantiated, or the instance of you as an object there, is bad. We can't use it. So when we're filling out characteristics, it is not things that may or may not be there. When we're filling out characteristics, it is things that absolutely will be there. You can argue that some of these will be there at a later time. So you cannot be a student if you have never taken a class. That much is true. You have to be registered at least for classes before you can be a student. We won't just hand you a student ID and say, hey, whatever, go for it. I guess walk around campus and see if you like it. You're official now. That should be okay. That'd be really weird and would probably illegal, so we wouldn't do that. Next, every object has a set of operations, and we call these methods. So in the example we went through the other session in class, it would be things like set username. It would be things like get username. It would be things like set last name, get last name, so on and so forth. And these methods are giving us a way to interact with this instance and every other instance of an object in a way that is full and complete, so that when you as an object travel from one portion of the system to another, so as a student travels from registration to the library, then they come back and they get financial aid, things of that nature, we know the full and complete list of how it is that we can interact with your object. Finally, every object is an instance of a class. So that means that we have it's called a super class. It's something that if we take another step back, potentially we could derive more or different kinds of objects that are vaguely similar but maybe not exactly the same. So if there was different kinds of students, if there was online only versus on-campus only students, student would be the class, and then the objects themselves would be something different. They would be online students or in-person students. So all of these things go together to create objects. The larger it is that the interaction between different elements of your program is going to be, the more probable it is that you want object-oriented design.